Assalamu alaikum. Hope you are doing fine. We know quantities that can be measured are known as physical quantities. We broadly classify them into fundamental and derived quantities. Derived quantities are expressed in terms of fundamental quantities. Fundamental quantities are otherwise known as base quantities. They are the dimensions of physical world. In this video, we are going to discuss the dimensions of a physical quality. Now, before going ahead, let me tell you what you mean by dimension. Dimension is nothing but the power of a physical quantity to which the fundamental quantity must be raised. I repeat, the dimension of a physical quantity is the power to which the fundamental quantity must be raised. You may find it a little difficult to understand. I will explain this to you with the help of a simple example. I take a derived quantity. Let me take a velocity. Velocity is a derived quantity, which is nothing but the rate of change of displacement. In simple words, we can write displacement divided by time is velocity. Then how to write the dimension of velocity? The dimension of velocity is written in terms of the fundamental quantity. The fundamental quantity that represents displacement is length. Okay, you remember this. We always represent the dimension within a square bracket. Write this within a square bracket. This is the dimension divided by this time. It's a T. Okay, L stands for length, that represents the displacement, and T stands for time. This is the dimension of displacement. This is the dimension of time. This together gives the dimension of velocity. Now, I told you dimension is nothing but the power of a fundamental quantity. But here we have only a fundamental quantity, but there is no power. You remember this, whenever you do not find a power in a given quantity, that means the power is 1. For your better understanding, I write it here. X can be written as x power 1. Okay, when there is no power means the power is 1. So really we do not write that. So what is the power here? Power is 1. The same here as well. So this can be written in this manner. Now we have t in the denominator. If I take it to numerator, then it takes this form. L power 1 in this way, then this t will become t power minus 1, because it is taken to numerator from the denominator. I hope you have understood. Here 1 by x, 1 upon x can be written as x power minus 1. The same thing we have followed here. But usually we represent the dimension of any physical quantity in terms of mass, length and time. Here we have length and time. There is no mass is given here. So what I do, I follow this method here. Look at it carefully. Now I take m, write this within square bracket. Now to keep the value as such, what I do, I raise m to the power 0. Correct? When something have power as 0, then its value is equal to 1. You remember this. So m power 0 is 1. Not only m. If you take L power 0, then its value is 1. If you take a t power 0, its value is 1. Whatever it may be. So in general, I take x power 0 equals to what? 1. You remember this. Okay. So its value is 1. When 1 is multiplied with something, the value is not going to change. So I write these things here as such. When the power is 1, it is not necessary to mention that. You can omit it. T power minus 1. This is the dimension of velocity. This can be written in this way. Instead of writing so many bracket, I open a square bracket, then I write all these things within it. M power 0, L power 1, T power minus 1. I close the bracket. This is the dimension of velocity. What I have done? I have written velocity in terms of fundamental quantities which have some power. These powers to which the fundamental quantities are raised is referred as dimension. I hope you have understood. Now, what does it say? It says that the dimension of velocity have 0 in mass, 1 in length, and minus 1 in time. This is what it means. I hope you have understood. Now, let me provide some basic information about dimension now. I told you earlier, dimension is nothing but the power of a physical quantity to which the fundamental quantities must be raised. Right? When we talk about fundamental quantity, which otherwise known as base quantity, there are 7 fundamental quantities are there. How many fundamental quantities are there? 7 fundamental quantities. Here FQ stands for fundamental quantities. What are they? They are as follows. This length. The dimension of length is written as L within bracket. Then next we have the dimension of mass. Okay. Then the dimension of time is written as T within bracket. Here length, mass and time. These 3 dimensions are usually used in mechanics. You remember this. The next we have temperature. Temperature have dimension represented letter K within a bracket. It is used in thermodynamics. Then next fundamental quantity we have is electric current. Electric current is measured in ampere. So here the dimension of electric current is E, written within bracket. So in electricity we use this dimension. Then next fundamental quantity is nothing but amount of substance, which is written as MOL within bracket. This is the dimension of amount of substance. Then last thing left here is dimension of luminous intensity. The dimension of luminous intensity is written as CD within a bracket, square bracket. Here CD stands for candela and MOL stands for mole. A stands for ampere and K stands for Kelvin, which is the unit of the measurement of temperature. I hope you have understood. We'll go ahead. Now we will deal with a few basic terms related to dimension. First is dimensional formula. What is this dimensional formula? Dimensional formula. Dimensional formula is nothing but the expression used to represent a physical quantity. Like here we have, no? We have velocity. Velocity is displacement divided by time. Here S stands for displacement. This is a dimensional formula. I repeat, dimensional formula is an expression used to represent the dimension of a physical quantity. Clear? Here this shows us the different fundamental quantities used to represent that particular physical quantity. Next thing we have is the dimensional equation. Dimensional equation. When the dimensional formula is represented in the form of an equation, then we call it as dimensional equation. Here is the example. The dimension of velocity is represented as n power 0, l power 1, t power minus 1. It is nothing but the dimensional equation of velocity. Clear? I repeat, when the dimensional formula is represented in the form of an equation, it is known as dimensional equation. Then now I'll show you how we can classify quantities based on the dimension. Based on the presence and absence of dimension, we can classify quantities into two. One is the dimensional quantity, another one is a dimensionless quantity. First we'll discuss about dimensional quantity. Physical quantities which have dimension are referred as dimensional quantities. These are classified as dimensional variable and a dimensional constant. It is classified as dimensional variable and a dimensional constant. A physical quantity which has got dimension and the value is not same is referred as dimensional variable. Let me repeat this once again. Physical quantities which possess a dimension and have variable values are referred as dimensional variables. For example, we have velocity, acceleration, force. These are all the examples of dimensional variables. When we talk about the physical quantities which have dimension and a fixed value, referred as dimensional constants, like For example, we have a gravitational constant, then a Planck's constant, small k. These are all examples of dimensional constants. Then we have a dimensionless quantities. Dimensionless quantity. It is again classified as dimensionless variable and a constant in the similar way. First, dimensionless variable and dimensionless constant. What is the dimensionless variable? A physical quantity which do not have dimension, but the value varies, means we call such physical quantity as dimensionless variable. Like we have a strain, then specific gravity, then refractive index. So all examples of dimensionless variable. They have different values, but they do not possess dimension. Next is dimensionless constant. A physical quantity which do not have dimension, but the value is fixed, is referred as dimensionless constant. Like we have a pi and e. These are examples of dimensionless constant. So that's all about the classification of physical quantities based on the dimension. Then we'll discuss one important topic known as principle of homogeneity. Homogeneity of dimensions. What is this principle of homogeneity? Let me tell you. If there is an equation, well, I write a simple equation here, a plus b equals to c. If I have an equation of this kind, then principle of homogeneity says that each term of this equation will have the same dimension. I repeat, each term of an equation will have the same dimension. It is known as principle of homogeneity. I take one example. I take a first equation of motion, v equals to u plus at. Here v stands for final velocity, u stands for initial velocity, a is acceleration and t is a time. We know the dimension of velocity, that's nothing but L t power minus 1. So in the place of these things, I am going to mention their dimension. Okay, let me do that here. In the place of v, its dimension is L t power minus 1. Then within bracket equals to, then initial velocity will also have the same dimension, L t power minus 1 within bracket. Then we have acceleration. What is this acceleration? Let me tell you. Acceleration is the rate of change of velocity. Velocity divided by time is acceleration. So the dimension of this one, Lt power minus 1 divided by t. So what do you get? The dimension obtained is Lt power minus 2. This is the dimension of acceleration that I mentioned here. So plus Lt power minus 2, then it is multiplied with time. Dimension of time is t. Okay. Now, you see, here we have Lt power minus 1, here also we have Lt power minus 1. Here Lt power minus 2 is multiplied with t. When we write t, that means power is 1. Its power is 1. See, here t power 1, when multiplied t power minus 1, minus 2, we get t power minus 1. So, finally we get this. Lt power minus 1 is equal to Lt power minus 1 here. This and this get cancelled. In the place of this we have Lt power minus 1. Lt power minus 1. So, this I write here Lt power minus 1. Now, if you look at this, the dimension of each term of this equation is same. See, Lt power minus 1, Lt power minus 1, and here also Lt power minus 1. So this shows that the given equation is dimensionally correct. So we call this as principle of homogeneity. I hope the video is useful. If you have any kind of doubt related to the topic, can you put your question in the comment section. Thanks for watching.